Hello, everyone, and welcome to this interesting session on machine learning. Before we move forward with our session, let's have a quick look at the agenda. So, first of all, I'll be starting with an introduction to data science, wherein I'll discuss how the growth of data led to the introduction of data science and how machine learning became a very important part of data science. So then again, we'll discuss what exactly is machine learning and the various application of machine learning in the day-to-day life and in the industry as well. And moving forward, we'll discuss the various types of machine learning, which are namely the supervised, unsupervised, and the reinforcement learning. And we'll discuss all of these three types of machine learning in depth, wherein I'll discuss the various algorithms which are present in these supervised, unsupervised, and unsupervised learning. And we'll discuss what is the math behind all of these algorithms, how these algorithms works. We'll also have quite a few demos in this session, so stay tuned to learn more about machine learning. So let's get started. Now, data as we know is increasing at a very alarming rate, and we are generating 2.5 quintillion bytes of it every day. We are living in an era of technological transformation that is bringing about changes in the way we take decisions. As big data is becoming pervasive across all the industries, use of machines to find patterns and predict futures is gaining a lot of prominence in the market. Now, what better way to discuss the growth of data generation and subsequent workplace demand than with some sound statistics? So let me start with a few lines or the data points that were published in a McKinsey report. So the report stated that the United States alone faces a shortage of 140,000 to 190,000 people with analytical expertise and 1.5 million managers and analysts with the skills to understand and make decisions based on the analysis of big data. Now pay attention to the words with the skills to understand and make decisions based on the analysis of big data. The industry will require a lot of big data and machine learning experts and needs even more about 10% people who can make decisions based on the analysis even though they might not be experts on machine learning. So what exactly is data science? So data science is also known as data-driven science, and it is an interdisciplinary field about scientific methods, processes, and systems to extract knowledge or insights from the data in various forms, either structured or unstructured. It is the study where information comes from, what it represents, and how it can be turned into a valuable resource in the creation of business and IT strategies. Now, data science employs many techniques and theories from fields like mathematics, statistics, information science, and computer science. It can be applied to small data sets. Also, yet, most people think data science is when you are dealing with big data or large amounts of data. Now, if you have a look at the peripherals of the data science, we have statistics, we have different programming languages, we have R, Python, we have SS. Then again, we have software, which we deal with, in which we bundle up our whole model and present the findings to the customer or wherever it is required. Then again, we have machine learning, which is the main topic of our session today. And then again, finally, we have big data. So let's focus on machine learning today and understand what exactly is machine learning. Machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Now, getting computers to program themselves and also teaching them to make decisions using data, where writing software is a bottleneck, let the data do the work instead. Now, machine learning is a class of algorithms which is data driven. That is, unlike normal algorithms, it is the data that tells what the good answer is. So, if we have a look at the various features of machine learning, first of all, it uses the data to detect patterns in a dataset and adjust the program actions accordingly. It focuses on the development of computer programs that can teach themselves to grow and change when exposed to new data. So it's not just the old data on which it has been trained. So whenever a new data is entered, the program changes accordingly. It enables computers to find hidden insights using iterative algorithms without being explicitly programmed either. So machine learning is a method of data analysis that automates analytical model building. Now let's understand how exactly it works. So if we have a look at the diagram which is given here, we have traditional programming on one side, we have machine learning on the other. So first of all, in traditional programming, what we used to do was provide the data, provide the program, and the computer used to generate the output. So things have changed now. So in machine learning, what we do is provide the data and we provide a predicted output to the machine. Now, what the machine does is learns from the data, find hidden insights, and creates a model. Now, it takes the output data also again, and it reiterates and trains and grows accordingly, so that the model gets better every time it is trained with the new data or the new output. So the first and the foremost application of machine learning in the industry I would like to get your attention towards is the navigation or the Google Maps. So Google Maps is probably the app we use whenever we go out and require assistance in directions and traffic, right? The other day I was traveling to another city and took the expressway, and the map suggested, despite the heavy traffic, you are on the fastest route. No, but how does it know that? Well, it's a combination of people currently using the services, the historic data of that route collected over time, and a few tricks acquired from the other companies. Now, everyone using maps is providing their location, their average speed, the route in which they are traveling, which in turn helps Google collect massive data about the traffic, which makes them predict the upcoming traffic and adjust your route according to it, which is pretty amazing, right? Now, coming to the second application, which is the social media, if we talk about Facebook. So, one of the most common application is automatic friend tagging suggestion in Facebook. And I'm sure you might have gotten this. So, it's present in all the other social media platform as well. So, Facebook uses face detection and image recognition to automatically find the face of the person which matches its database. And hence, it suggests us to tag that person based on deep face. Now, Deepface is Facebook's machine learning project, which is responsible for recognition of faces and identifying which person is in the picture. And it also provides alternative tags to the images already uploaded on Facebook. So, for example, if we have a look at this image and we inspect the following image on Facebook, we get the alt tag which has a particular description. So, in our case, what we get here is the image may contain sky, grass, outdoor, and nature. Now, transportation and commuting is another industry where machine learning is used heavily. So, if you have used an app to book a cab recently, then you are already using machine learning to an extent. Now, what happens is that it provides a personalized application which is unique to you. It automatically detects your location and provides option to either go home or office or any other frequent places based on your history and patterns. It uses machine learning algorithm layered on top of historic trip data to make more accurate ETA predictions. Now, Uber, with the implementation of machine learning on their app and their website, saw a 26% accuracy in delivery and pickup. That's a huge up point. Now, coming to the virtual person assistant, as the name suggests, virtual person assistant assists in finding useful information when asked via voice or text. Few of the major applications of machine learning here are speech recognition, speech to text conversion, natural language processing, and text to speech conversion. All you need to do is ask a simple question like, "What is my schedule for tomorrow?" or "Show my upcoming flights." Now, for answering, your personal assistant searches for information or recalls your related queries to collect the information. Recently, personal assistants are being used in chatbots, which are being implemented in various food ordering apps, online training websites, and also in commuting apps as well. Again, product recommendation. Now, this is one of the areas where machine learning is absolutely necessary, and it was one of the few areas which emerged the need for machine learning. Now, suppose you check an item on Amazon, but you do not buy it then and there. But the next day you are watching videos on YouTube and suddenly you see an ad for the same item. You switch to Facebook, there also you see the same ad, and again you go back to any other site and you see the ad for the same sort of items. So how does this happen? Well, this happens because Google tracks your search history and recommends ads based on your search history. This is one of the coolest applications of machine learning, and in fact 35% of Amazon's revenue is generated by the product's recommendation. Now, coming to the cool and highly technological side of machine learning, we have self-driving cars. If we talk about self-driving car, it's here and people are already using it. Now, machine learning plays a very important role in self-driving cars, as I'm sure you guys might have heard about Tesla, the leader in this business, and their current artificial intelligence is driven by the hardware manufacturer Nvidia, which is based on unsupervised learning algorithm, which is a type of machine learning algorithm. Now, Nvidia stated that they did not train their model to detect people or any of the objects as such. The model works on deep learning and crowdsources its data from the other vehicles and its drivers. It uses a lot of sensors which are a part of IoT, and according to the data gathered by McKinsey, the automotive data will hold a tremendous value of $750 billion. Now that's a lot of dollars we are talking about here. Now next again we have Google Translate. Now remember the time when you travel to the new place and you find it difficult to communicate with the locals or finding local spots where everything is written in a different languages. Well, those days are gone. Google's GNMT, which is the Google Neural Machine Translation, is a neural machine learning that works on thousands of languages and dictionary. It uses natural language processing to provide the most accurate translation of any sentence or words. Since the tone of the word also matters, it uses other techniques like POS tagging, name entity recognition, and chunking. And it is one of the most used applications of machine learning. Now, if we talk about dynamic pricing, setting the right price for a goods or a service is an old problem in economic theory. There are a vast amount of pricing strategies that depend on the objective sought. Be it a movie ticket, a plane ticket, or a cab fare, everything is dynamically priced. Now, in recent years, machine learning has enabled pricing solutions to track buying trends and determine more competitive product prices. Now, if we talk about Uber, how does Uber determine the price of your ride? Uber's biggest use of machine learning comes in the form of search pricing, a machine learning model named as GeoSearch. If you are getting late for a meeting and you need to book an Uber in a crowded area, get ready to pay twice the normal fare. Even for flights, if you are traveling in the festive season, the chances are that prices will be twice as much as the original price. Now, coming to the final application of machine learning we have is the online video streaming. We have Netflix, Hulu, and Amazon Prime Video. Now, here I'm going to explain the application using the Netflix example. So, with over 100 million subscribers, there is no doubt that Netflix is the daddy of the online streaming world. When Netflix's speedy rise has all the movie industrialists taken aback, forcing them to ask, how on earth could one single website take on Hollywood? Now, the answer is machine learning. The Netflix algorithm constantly gathers massive amounts of data about user activities like when you pause, rewind, fast forward, what do you watch the content, TV shows on weekdays, movies on weekend, the date you watch, the time you watch, whenever you pause and leave a content, so that if you ever come back, they will suggest the same video. The rating events, which are about 4 million per day, the searches, which are about 3 million per day, the browsing and the scrolling behavior, and a lot more. Now they collect this data for each subscriber they have and use the recommender system and a lot of machine learning applications. And that is why they have such a huge customer retention rate. So I hope these applications are enough for you to understand how exactly machine learning is changing the way we are interacting with the society and how fastly it is affecting the world in which we live in. So if we have a look at the market trend of the machine learning here, so as you can see, initially it wasn't much in the market. But if you have a look at the 2016 side, there was an enormous growth in machine learning. And this happened mostly because, earlier we had the idea of machine learning, but then again, we did not have the amount of big data. So as you can see, the red line we have here in the histogram and the bar plot is that of the big data. So big data also increased during the years, and which led to the increase in the amount of data generated. And recently we had that power, or I should say the underlying technology and the hardware to support that power that makes us create machine learning programs that will work on this big data. So that is why you see very high inclination during the 2016 period time as compared to 2012. So because during 2016 we got new hardware and we were able to find insights using those hardware and program and create models which would work on heavy data. Now let's have a look at the life cycle of machine learning. So a typical machine learning life cycle has 6 steps. So the first step is collecting data. Second is data wrangling. Then we have the third step where we analyze the data. Fourth step where we train the algorithm. The fifth step is when we test the algorithm. And the sixth step is when we deploy that particular algorithm for industrial uses. So when we talk about the first step, which is collecting data, so here data is being collected from various sources, and this stage involves the collection of all the relevant data from various sources. Now, if we talk about data wrangling, so data wrangling is the process of cleaning and converting raw data into a format that allows convenient consumption. Now, this is a very important part in the machine learning lifecycle, as it's not every time that we receive a data which is clean and is in a proper format. Sometimes there are values missing, sometimes there are wrong values, sometimes data format is different. So a major part in a machine learning lifecycle goes in data wrangling and data cleaning. So if we talk about the next step, which is data analysis, so data is analyzed to select and filter the data required to prepare the model. So in this step, we take the data, use machine learning algorithms to create a particular model. Now, next again, when we have a model, what we do is train the model. Now, here we use the data sets, and the algorithm is trained on the training data set through which algorithm understand the pattern and the rules which govern the particular data. Once we have trained the algorithm, next comes testing. So the testing data set determines the accuracy of our model. So what we do is provide the test data set to the model, and which tells us the accuracy of the particular model, whether it's 60%, 70%, 80%, depending upon the requirement of the company. And finally, we have the operation and optimization. So if the speed and accuracy of the model is acceptable, then that model should be deployed in the real system. The model that is used in the production should be made with all the available data. Models improve with the amount of available data used to create the model. The result of the model needs to be incorporated in the business strategy. Now, after the model is deployed, based upon its performance, the model is updated and improved. If there is a dip in the performance, the model is retrained. So all of these happen in the operation and optimization stage. Now, before we move forward, since machine learning is mostly done in Python and R, and if we have a look at the difference between Python and R, I'm pretty sure most of the people would go for Python. And the major reason why people go for Python is because Python has more number of libraries, and Python is being used in just more than data analysis and machine learning. So some of the important Python libraries here which I want to discuss here. So first of all, I'll talk about matplotlib. Now what matplotlib does is that it enables you to make bar charts, scatter plots, the line charts, histogram. Basically what it does is helps in the visualization aspect. As data analysts and machine learning engineers, what one needs to represent their data in such a format that it is used that it can be understood by non-technical people such as people from marketing, people from sales, and other departments as well. So another important Python library here we have is Seaborn, which is focused on the visuals of statistical models, which includes heat maps and depict the overall distributions. Sometimes people work on data which are more geographically aligned, and I would say in those cases heat maps are very much required. Now next we come to scikit-learn, and scikit-learn is one of the most famous libraries of Python, I would say. It's simple and efficient for data mining and for data analysis. It is built on NumPy and Matplotlib, and it is open source. Next on our list we have Pandas. It is the perfect tool for data wrangling, which is designed for quick and easy data manipulation, aggregation, and visualization. And finally, we have NumPy. Now, NumPy stands for Numerical Python. It provides an abundance of useful features for operation on n arrays, which are the NumPy arrays, and matrices in Python. And mostly it is used for mathematical purposes, so which gives a plus point to any machine learning algorithm. So guys, these were the important Python libraries which one must know in order to do any Python programming for machine learning, or as such, if you are doing Python programming, you need to know about all of these libraries. So guys, next what we are going to discuss are the types of machine learning. So then again, we have three types of machine learning, which are supervised, reinforcement, and unsupervised machine learning. So if we talk about supervised machine learning, so supervised learning is where you have the input variables x and the output variable y, and you use an algorithm to learn the mapping function from the input to the output. So if we take the case of object detection here, or face detection, I would rather say. So first of all, what we do is input the raw data in the form of labeled faces. And again, it's not necessary that we just input faces to train the model. What we do is input a mixture of faces and non-faces images. So as you can see here, we have labeled face and labeled non-faces. What we do is provide the data to the algorithm. The algorithm creates a model. It uses the training data set to understand what exactly is in a face, what exactly is in a picture which is not a face. And after the model is done with the training and processing, so to test it, what we do is provide particular input of a face or a non-face. What we know, see, the major part of supervised learning here is that we exactly know the output. So when we are providing a face, we ourselves know that it's a face. So to test that particular model and get the accuracy, we use the labeled input raw data. So next, when we talk about unsupervised learning is the training of a model using information that is neither classified nor labeled. Now, this model can be used to cluster the input data in classes or the basis of their statistical properties. For example, for a basket full of vegetables, we can cluster different vegetables based upon their color or sizes. So if I have a look at this particular example here we have, what we are doing is we are inputting the raw data, which can be either apple, banana, or mango. What we don't have here, which was previously there in supervised learning, are the labels. So what the algorithm does is that it visually gets the features of a particular set of data. It makes clusters. So what will happen is that it will make a cluster of red looking fruits, which are apple, yellow looking fruits, which are banana, and based upon the shape also, it determines what exactly the fruit is and categorizes it as mango, banana, or apple. So this is unsupervised learning. Now, the third type of learning which we have here is reinforcement learning. So, reinforcement learning is the learning by interacting with a space or an environment. It selects the action on the basis of its past experience, the exploration, and also by new choices. A reinforcement learning agent learns from the consequences of its action rather than from being taught explicitly. So, if we have a look at the example here, the input data we have, what it does is goes to the agent, where the agent selects the algorithm, it takes the best action from the environment, gets the reward, and the model is trained. So if you provide a picture of a green apple, although the apple which it particularly knows is red, what it'll do is it will try to get an answer, and with the past experience what it has, and it will reiterate the algorithm and then finally provide an output which is according to our requirements. So now these were the three major types of machine learning algorithms. Next, what we're going to do is dig deep into all of these types of machine learning one by one. So let's get started with supervised learning first and understand what exactly is supervised learning and what are the different algorithms inside it, how it works, the algorithms, the working, and we'll have a look at the various algorithm demos now, which will make you understand it in a much better way. So let's go ahead and understand what exactly is supervised learning. So supervised learning is where you have the input variable x and the output variable y, and you use an algorithm to learn the mapping function from the input to the output, as I mentioned earlier with the example of face detection. So it is called supervised learning because the process of an algorithm learning from the training dataset can be thought of as a teacher supervising the learning process. So if we have a look at the supervised learning steps, or what we'd rather say the workflow. So the model is used, as you can see here, we have the historic data, then we have the random sampling. We split the data into training dataset and the testing dataset. Using the training dataset, with the help of machine learning, which is supervised machine learning, we create statistical model. And then after we have a model which is being generated with the help of the training dataset, what we do is use the testing dataset for prediction and testing. What we do is get the output, and finally we have the model validation outcome. That was the training and testing. So if we have a look at the prediction part of any particular supervised learning algorithm, so the model is used for predicting outcome of a new dataset. So whenever performance of the model degraded, the model is retrained, or if there are any performance issues, the model is retrained with the help of the new data. Now, when we talk about supervised learning, there are not just one, but quite a few algorithms here. So we have linear regression, logistic regression, decision tree, we have random forest, we have naive Bayes classifiers. So linear regression is used to estimate real values. For example, the cost of houses, the number of calls, the total sales, based on the continuous variables. So that is what linear regression is. Now, when we talk about logistic regression, it is used to estimate discrete values, for example, which are binary values like 0 and 1, yes or no, true and false, based on the given set of independent variables. So, for example, when we are talking about something like the chances of winning, or if we talk about winning, which can be the true or false, if will it rain today, it can be the yes or no. So it cannot be like when the output of a particular algorithm or the particular question is either yes, no, or a binary, then only we use a logistic regression. Now, next we have decision trees. So now these are used for classification problems. It works for both categorical and continuous dependent variables. And if we talk about random forest, so random forest is an ensemble of a decision tree. It gives better prediction and accuracy than decision tree. So that is another type of supervised learning algorithm. And finally, we have the naive Bayes classifier. So it is a classification technique based on the Bayes theorem with an assumption of independence between predictors. So we'll get more into the details of all of these algorithms one by one. So let's get started with linear regression. So first of all, let's understand what exactly linear regression is. So linear regression analysis is a powerful technique used for operating the unknown value of a variable, which is the dependent variable, from the known value of another variable, which is the independent variable. So a dependent variable is the variable to be predicted or explained in a regression model, whereas an independent variable is a variable related to the dependent variable in a regression equation. So if we have a look here at the simple linear regression, so it's basically equivalent to a simple line which is with a slope which is y equals a plus bx, where y is the dependent variable, a is the y-intercept, we have b which is the slope of the line, and x which is the independent variable. So intercept is the value of the dependent variable y when the value of the independent variable x is 0. It is the point at which the line cuts the y-axis, whereas slope is the change in the dependent variable for a unit increase in the independent variable. It is the tangent of the angle made by the line with the x-axis. Now when we talk about the relation between the variables, we have a particular term which is known as correlation. So correlation is an important factor to check the dependencies when there are multiple variables. What it does is it gives us an insight of the mutual relationship among variables, and it is used for creating a correlation plot with the help of the Seaborn library, which I mentioned earlier, which is one of the most important libraries in Python. So correlation is very important term to know about. Now if we talk about regression lines, so linear regression analysis is a powerful technique used for predicting the unknown value of a variable, which is the dependent variable, from the regression line, which is simply a single line that best fits the data in terms of having the smallest overall distance from the line to the points. So as you can see in the plot here, we have the different points or the data points. So these are known as the fitted points. Then again, we have the regression line, which has the smallest overall distance from the line to the points. So if we have a look at the distance between the point to the regression line, so what this line shows is the deviation from the regression line. So exactly how far the point is from the regression line. So let's understand a simple use case of linear regression with the help of a demo. So first of all, there is a real estate company use case, which I'm going to talk about. So first of all, here we have John. He has some baseline for pricing the villas and the independent houses he has in Boston. So here we have the dataset description, which we're going to use. So this dataset has different columns such as the crime rate per capita, which is CRIM. It has a proportion of residential land zoned for the lots, proportion of non-retail business, the river, the nitric oxide concentration, average number of rooms, the proportion of the owner occupying the built prior to 1940, the distance of the 5 Boston employment centers, indexes of accessibility to radial highways, and much more. So first of all, let's have a look at the data set we have here. So one important thing here, guys, is that I'm going to be using Jupyter Notebook to execute all my practicals. You are free to use the Spider Notebook or the console either. So it basically comes down to your preference. So for my preference, I'm going to use the Jupyter Notebook. So for this use case, we're going to use the Boston housing dataset. So guys, as you can see here, we have the dataset which has the CRIM, ZN, Indus, CAH, NOx, the different variables, and we have the dataset of almost, I would say, like 500 houses. So what John needs to do is plan the pricing of the housing depending upon all of these different variables so that it's profitable for him to sell the house and it's easier for the customers also to buy the house. So first of all, let me open the code here for you. So first of all, what we're going to do is import the libraries necessary for this project. So we're going to use the NumPy. We're going to import NumPy as NP, import pandas as PD. Then we're going to also import the matplotlib. And then we are going to do is read the Boston housing dataset into the BOS1 variable. So now what we're going to do is create two variables x and y. So what we're going to do is take 0 to 13, I'd say is from CRIM to LSTAT in one x, because that's the independent variable, and y here is the dependent variable, which is the MEDV, which is the final price. So first of all, what we need to do is plot a correlation. So what we're going to do is import the Seaborn library as SNS. We're going to use the correlations to plot the correlation between the different 0 to 13 variables. What we're going to do is also use MEDV here also. So what we're going to do is sns.heatmap correlations. We're going to use the square to differentiate. Usually it comes up in square only or circles. So you don't know. So we're going to use square. We're going to use CMAP with the YLGNBU. This is the color. So there's no rotation in the y-axis, and we're going to rotate the x-axis to the 90-degree. And we're going to plot it now. So this is what the plot looks like. So as you can see here, the more thicker or the more darker the color gets, the more is the correlation between the variables. So for example, if we have a look at CRIM and MEDV, right? So as you can see here, the color is very less, so the correlation is very low. So one thing important what we can see here is the tax and RAD, which is the full value of the property, and RAD is the index of accessibility to the radial highways. Now, these things are highly correlated. And that is natural because the more it is connected to the highway and more closer it is to the highway, the more easier it is for people to travel, and hence the tax on it is more as it is closer to the highways. Now what we're going to do is from sklearn.cross-validation, we're going to import the train test split. And we're going to split the data set now. So what we are going to do is create four variables, which are the xtrain, xtest, ytrain, ytest, and we're going to use the train test split function to split the x and y. And here we're going to use the test size 0.33, which will split the dataset into the test size will be 33%, whereas the training size will be 67%. Now this is dependent on you. Usually it is either 60, 40, 70, 30. This depends on your use case, your data you have, the kind of output you are getting, the model you are creating, and much more. Then again, from sklearn.linear model, we're going to import linear regression. Now, this is the major function we're going to use here. It is linear regression function, which is present in sklearn, which is the scikit-learn. So we're going to create our linear regression model into LM, and the model which we're going to create, and we're going to fit the training variables, which are the xtrain and the ytrain, and then we're going to create a prediction underscore y, which is the lm.predict, and it will take the x test variables, which will provide the predicted y variables. So now finally, if we plot the scatter plot of the y test and the y predicted, what we can see is that, and we give the x label as y test and the y label as y predicted, we can see the regression line which we have plotted here, the scatter plot. And if you want to draw a regression line, it will go through all of these points, excluding the extremities which are here present at the endpoints. So this is how a normal linear regression works in Python. What you do is create a correlation, you find out, you split the dataset into training and testing variables. Then again, you define what is going to be your test size, import the linear regression model, use the training dataset into the model fitted, use the test dataset to create the predictions, and then use the y underscore test and the predicted y and plot the scatter plot and see how close your model is doing with the original data it had and check the accuracy of that model. Now, typically, you use these tests, which was collecting data, what we did, data wrangling, analyze the data, we trained the algorithm, we use the test algorithm, and then we deployed. So, fitting a model means that you are making your algorithm learn the relationship between predictors and the outcomes so that you can predict the future values of the outcome. So, the best fitted model has a specific set of parameters which best defines the problem at hand. Since this is a linear model with the equation y equals mx plus c, so in this case the parameters of the model learns from the data that are m and c. So this is about model fitting. Now if we have a look at the types of fitting which are available. So first of all, machine learning algorithms first attempt to solve the problem of underfitting. That is, of taking a line that does not approximate the data well and making it approximate to the data better. So, machine does not know where to stop in order to solve the problem, and it can go ahead from appropriate to overfit model sometimes. When we say a model overfits a dataset, we mean that it may have a low error rate for training data, but it may not generalize well to the overall population of the data we are interested in. So, we have underfit, appropriate, and overfit. These are the types of fitting. Now guys, this was linear regression, which is a type of supervised learning algorithm in machine learning. So next what we're going to do is understand the need for logistic regression. So let's consider a use case as in political elections are being contested in our country. And suppose that we are interested to know which candidate will probably win. Now the outcome variables result in binary, either win or lose. The predictor variables are the amount of money spent, the age, the popularity rank, and etc. etc. Now here the best fit line in the regression model is going below 0 and above 1. And since the value of y will be discrete, that is between 0 and 1, the linear line has to be clipped at 0 and 1. Now linear regression gives us only a single line to classify the output. With linear regression, our resulting curve cannot be formulated into a single formula as we obtain three different straight lines. What we need is a new way to solve this problem. So hence people came up with logistic regression. So let's understand what exactly is logistic regression. So logistic regression is a statistical method for analyzing a dataset in which there are one or more independent variables that determine an outcome. And the outcome is a binary class type. So, for example, a patient goes for a routine checkup in the hospital and he's interested to know whether the cancer is benign or malignant. Now, a patient's data, such as sugar level, blood pressure, age, skin width, and the previous medical history, are recorded, and the doctor checks the patient data and determines the outcome of his illness and severity of illness. The outcome will result in binary, that is, 0 if the cancer is malignant and 1 if it's benign. Now, logistic regression is a statistical method used for analyzing a dataset in which there are one or more dependent variables like we discussed, like the sugar level, blood pressure, age, skin width, the previous medical history, and the output is binary class type. So now let's have a look at the logistic regression curve. Now the logistic regression curve is also called a sigmoid curve or the S-curve. The sigmoid function converts any value from minus infinity to the discrete values 0 or 1. Now how to decide whether the value is 0 or 1 from this curve? So let's take an example. What we do is provide a threshold value. We set it, we decide the output from that function. So let's take an example with a threshold value of 0.4. So any value above 0.4 will be rounded off to 1 and anyone below 0.4 will be reduced to 0. So similarly, we have polynomial regression also. So when we have nonlinear data which cannot be predicted with a linear model, we switch to the polynomial regression. Now such a scenario is shown in the below graph. So as you can see here, we have the equation y equals 3x cubed plus 4x squared minus 5x plus 2. Now here we cannot perform this linearly. So we need polynomial regression to solve these kind of problems. Now when we talk about logistic regression, there is an important term which is decision tree. And this is one of the most used algorithms in supervised learning. Now let's understand what exactly is a decision tree. So a decision tree is a tree-like structure in which internal node represents tests on an attribute. Now each attribute represents outcome of test, and each leaf node represents the class label, which is the decision taken after computing all attributes. A path from root to the leaf represents classification rules, and a decision tree is made from our data by analyzing the variables from the decision tree. Now from the tree we can easily find out whether there will be game tomorrow if the conditions are rainy and less windy. Now let's see how we can implement the same. So suppose here we have a data set in which we have the outlook. So what we can do is from each of the outlooks we can divide the data as sunny, overcast and rainy. So as you can see in the sunny side we get 2 yeses and 3 nos because the outlook is sunny, the humidity is normal and the wind is weak and strong. So it's a fully sunny day. What we have here is that it's not a pure subset, so what we're going to do is split it further. So if we have a look at the overcast, we have humidity high, normal weak. So yes, during overcast we can play. And if we have a look at the rainy area, we have 3 yeses and 2 no. So again, what we're going to do is split it further. So when we talk about sunny, then we have humidity. In humidity, we have high and normal. So when the humidity is normal, we're going to play, which is the pure subset. And if the humidity is high, we're not going to play, which is also a pure subset now. So let's do the same for the rainy day. So during rainy day, we have the wind classifier. So if the wind is weak, it becomes a pure subset, we're going to play. And if the wind is strong, it's a pure subset, we're not going to play. So the final decision tree looks like this. So first of all, we check if the outlook is sunny, overcast or rainy. If it's overcast, we will play. If it's sunny, we then again check the humidity. If the humidity is high, we will not play. If the humidity is normal, we will play. When again, in the case of rainy, we check the wind. If the wind is weak, the play will go on. And similarly, if the wind is strong, the play must stop. So this is how exactly a decision tree works. So let's go ahead and see how we can implement logistic regression in decision trees. Now for logistic regression, we're going to use the cancer data set. So this is how the data set looks like. So here we have the ID diagnosis, radius mean, texture mean, parameter mean. These are the stats of particular cancer cells or the cysts which are present in the body. So we have like total 33 columns, all the way starting from ID to unnamed 32. So our main goal here is to define whether, or I'd say predict whether the cancer is benign or malignant. So first of all, what we're going to do is from scikit-learn.model selection, we're going to import cross-validation score. And again, we're going to use NumPy for linear algebra. We're going to use pandas as PD because for data processing. The CSV file input for data manipulation in SQL and most of the stuff. Then we're going to import the matplotlib. It is used for plotting the graph. We're going to import Seaborn, which is used to plot interactive graph. Like in the last example we saw, we plotted a heat map correlation. So from sklearn, we're going to import the logistic regression, which is the major model or the algorithm behind the whole logistic regression. We're going to import the train test split so as to split the data into 2 paths, training and testing data set. We're going to import metrics to check the error and the accuracy of the model, and we're going to import decision tree classifier. So first of all, what we're going to do is create a variable data and use the pandas PD to read the data from the data set. So here the header 0 means that the 0th row is our column name, and if we have a look at the data or the top 6 part of the data, we're going to use the print data.head and get the data.info. So as you can see here, we have so many data columns such as ID diagnosis, radius mean, texture mean, perimeter mean, area mean, smoothness mean, we have texture, worst, symmetry worst, we have fractal dimension worst, and lastly we have the unnamed. So first of all, we can see we have 6 rows and 33 columns. And if we have a look at all of these columns here, right, we get the total number, which is the 569, which is the total number of observation we have, and we check whether it's non-null, and then again we check the type of the particular column. So it's integer, it's object, float. Mostly most of them are floats, some are integer. So Now again, we're going to drop the unnamed column, which is the column 32nd 0 to 33, which is the 32nd column. So in this process, we will change it in our data itself. So if you want to save the old data, you can also save that, but then again, that's of no use. So data.columns will give us all of these columns when we remove that. So as you can see here in the output, we do not have the final one, which was the unnamed. The last one we have is D type, which is float. So like this, we also don't want the ID column for our analysis. So what we're going to do is we're going to drop the ID again. So as I said above, the data can be divided into three parts. So let's divide the features according to their category. Now, as you know, our diagnosis column is an object type. So we can map it to the integer value. So what we're going to do is use the data diagnosis, and we're going to map it to M1 and B0, so that the output is either M or B. Now if we use the data.describe, so you can see here we have 8 rows and 1 columns because we dropped 2 of the columns. And in the diagnose we have the values here. Let's get the frequency of the cancer stages. So here we're going to use the Seaborn SNS dot count plot data with diagnosis and label count. And if we use the PLT dot show, so here you can see the diagnosis for 0 is more and for 1 is less. If we plot the correlation among this data, so we're going to use the plt.figure, sns.heatmap, we're going to use a heat map, we're going to plot the correlation C bar true, we're going to use square true, and we're going to use the cool warm technique. So as you can see here, the correlation of the radius worst with the area worst and the perimeter worst is more, whereas the radius worst has high correlation to the perimeter mean and the area mean, because if the radius is more, the perimeter is more, the area is more. So based on the core plot, let's select some features from the model. Now the decision is made in order to remove the collinearity. So we're going to have a prediction variable in which we have the texture mean, the perimeter mean, the smoothness mean, the compactness mean, and the symmetry mean. Now these are the variables which we'll use for the prediction. Now we're going to split the data into the training and testing data set. Now in this, our main data is split into training and test data set with the 0.3 test size, that is 30 to 70 ratio. Next, what we're going to do is check the dimension of the training and the testing data set. So what we're going to do is use the print command and pass the parameter train.shape and test.shape. So what we can see here is that we have almost like 398 observations with 31 columns in the training data set, whereas 171 rows and 31 columns in the testing data set. So then again, what we're going to do is taking the training data input, what we're going to do is create a train underscore x with the prediction underscore var, and train underscore y is for the diagnosis. Now this is the output of our training data, same as we did for the test. So we're going to use test underscore x for the test prediction variable and test underscore y for the test diagnosis, which is the output of the test data. Now we're going to create a logistic regression method and create a model logistic.fit, in which we're going to fit the training data set, which is train x and train y, and then we're going to use a TEMP, which is the temporary variable in which we're going to predict x. And then what we're going to do is we're going to compare TEMP, which is the test x, with the test y to check the accuracy. So the accuracy here we get is 0.91. Then again, what we need to do, this was logistic regression, normal logistic regression, we're going to use classifier. So we're going to create a decision tree classifier with random state given as 0. Now what next we're going to do is create the cross validation score, which is the CLF. We take the model, we take the train X, train Y, and CV equals 10, the cross validation score. Now if we fit the training, test, and the sample weight we have not defined here, check the input if it's true, and XIDX sorted is none. So if we get the parameters true, we predict using the test X and then predict the long probability of test X. And if we compare the score of the test X to test Y with the sample weight none, we get the same result as a decision tree. So this is how you implement a decision tree classifier and check the accuracy of the particular model. So that was it. So next in our list is random forest. So let's understand what exactly is a random forest. So random forest is an ensemble classifier made using many decision tree models. So So what exactly are ensemble models? So ensemble models combines the result from different models. The result from an ensemble model is usually better than the result of the one of the individual model because every tree votes for one class. The final decision is based upon the majority of votes. And it is better than decision tree because compared to decision tree, it can be much more accurate. It runs efficiently on large data set. It can handle thousands of input variables without variable deletion. And what it does is it gives an estimate of what variables are important in the classification. So let's take the example of weather data. So let's understand random forests with the help of the hurricanes and typhoons dataset. So we have the data about hurricanes and typhoons from 1851 to 2014, and the data comprises of location, wind, the pressure of tropical cyclones in the Pacific Ocean. Based on the data, we have to classify the storms into hurricanes, typhoons, and the subcategories as per the predefined classes mentioned. So the predefined classes are TD, tropical cyclone of tropical depression intensity, which is less than 34 knots. If it's between 34 to 63 knots, it's TS. Greater than 64 knots, it's HU, which is a hurricane intensity. EX is extratropical cyclone. ST is less than 34, it's a subtropical cyclone or subtropical depression. SS is greater than 34, which is a subtropical cyclone of subtropical storm intensity. And then again, we have LO, which is a low that is neither a tropical cyclone, a tropical subtropical cyclone, or not an extraterrestrial cyclone. And then again, finally, we have dB, which is disturbance of any intensity. Now, these were the predefined classes description. So as you can see, this is the data in which we have the ID, name, date, event status, latitude, longitude, maximum when, minimum when. There are so many variables. So let's start with importing the pandas. Then again, we import the matplotlib. Then we're going to use the aggregate method in matplotlib. We're going to use the matplotlib inline, which is used for plotting interactive graph. And I like it most for plots. So next what we're going to do is import Seaborn as SNS. Now this is used to plot the graph again, and we're going to import the model selection, which is the train test split. So we're going to import it from sklearn, the scikit-learn. We have to import metrics for checking the accuracy. Then we have to import sklearn. And then again from sklearn, we have to import tree. From sklearn.ensemble, we're going to import the random forest classifier. From sklearn.metrics, we're going to import confusion matrix so as to check the accuracy. And from sklearn.metrics, we're going to also import the accuracy score. So let's import random and let's read the data set and print the first 6 rows of the data sets. As you can see here, we have the ID, we have the name, date, time, event status, latitude, longitude. So in total, we have 22 columns here. So as you can see here, we have a column named status, which is TS, TS, TS for the first 6. So what we're going to do is data.status is equal to pd.categorical data.status. So what we're going to do is make it a categorical data with quotes so that it's easier for the machine to understand it. Rather than having certain categories as names, we're going to use the categories as numbers. So it's easier for the computer to do the analysis. So let's get the frequency of different typhoons. So what we're going to do is random.seed. Then again, what we're going to do is if we have to drop the status, we have to drop the event because these are unnecessary. We're going to drop latitude, longitude, we're going to drop ID, the name, the date, and the time it occurred. So if we print the prediction list, so ignore the error here. So that's not necessary. So we have the maximum wind, minimum wind pressure, low wind NE, low wind SE, low wind SW, and these are the parameters on which we're going to do the predictions. So now we'll split the data into training and testing data sets. So then again, we have the train comma test, and we're going to use the train test split and split it in the 70:30 industrial standard ratio. Now, important thing here to note is that you can split it in any form you want. Can be the 60/40, 70/30, 80/20. It all depends upon the model which you have or the industrial requirement which you have. So then again, if after printing, let's check the dimensions. So the training data set comprises of 18,295 rows with 22 columns, whereas the testing data set comprises of 8,000 rows with 22 columns. We have the training data input train X, we have to train Y, So status is the final output of the training data, which will tell us the status, whether it's a TS, TD, which it's an HU, which kind of a hurricane or typhoon, or any kind of subcategories which are defined, which were like subtropical cyclone, the subtropical typhoon, and much more. So our prediction or the output variable will be status. So these are the list of the training columns which we have here. Now same we have to do for the test variables. So we have the test X with the prediction underscore var, with the test Y with the status. So now what we're gonna do is build a random forest classifier. So in the model we have the random forest classifier with estimators as 100, a simple random forest model, and then we fit the training data set, which is a train X and train Y. Then we again make the prediction, which is the model.predict that with the test underscore X. And this will predict for the test data, and prediction will contain the predicted value by our model predicted values of the diagnosis column for the test inputs. So if you print the metrics of the accuracy score between the prediction and the test underscore Y, to check the accuracy, we get 95% accuracy here. Now the same if we're gonna do with decision tree. So again, we're gonna use the model tree dot decision tree classifier. We're gonna use the train X and train Y, which are the training data sets. And new prediction is model dot predict underscore text. We're gonna create a data frame, which is the pana dot data frame. And if we have a look at the prediction and the test underscore Y, you can see the status 10, 10, 3, 3, 10, 10, 11, and 5, 5, 3, 11, 3, 3. So it goes on and on. So it has 7,842 rows and one column. And if we print the accuracy, we get a 95.57% of accuracy. And if we have a look at the accuracy of the random forest, we get 95.66%, which is more than 95.57. So as I mentioned earlier, usually random forest gives a better output or creates a better model than the decision tree classifier, because as I mentioned earlier, it combines the result from different models, So the final decision is based upon the majority of votes and is usually higher than the decision tree models. So guys, let's move ahead with our naive Bayes algorithm, and let's see what exactly is naive Bayes. So naive Bayes is a simple but surprisingly powerful algorithm for predictive modeling. Now, it is a classification technique based on the Bayes theorem with an assumption of independence among predictors. It comprises of two parts, which are the naive and the Bayes. So in simple terms, a naive Bayes classifier assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature, even if these features depend on each other or upon the existence of the other features. All of these properties independently contribute to the probability that a fruit is an apple or an orange, and that is why it is known as naive. Now, naive-based model is easy to build and particularly useful for very large data sets. In probability theory and statistics, Bayes theorem, which is alternatively known as the Bayes law or the Bayes rule, also noted as Bayes theorem, describes the probability of an event based on the prior knowledge of conditions that might be related to the event. So Bayes theorem is a way to figure out the conditional probability. Now, conditional probability is the probability of an event happening given that it has some relationship to one or more other events. For example, your probability of getting a parking space is connected to the time of the day you park, where you park, and what conventions are going on at the same time. So Bayes theorem is slightly more nuanced, and in a nutshell, it gives us the actual probability of an event given information about tests. So let's talk about the Bayes theorem now. Now given an hypothesis H and evidence E, Bayes theorem states that the relationship between the probability of the hypothesis before getting the evidence PH and the probability of the hypothesis after getting the evidence, which is PH bar E, is PE bar H into probability of H divided by probability of E, which means it's the probability of event after getting the hypothesis into probability of the hypothesis divided by the probability of the evidence. So let's understand it with a simple example here. So now, for example, if a single card is drawn from a standard deck of playing cards, the probability of that card being a king is 4 out of 52. Now, since there are 4 kings in a standard deck of 52 cards, the rewarding this, if the king is the event, this card is a king, The prior probability of the king, that is the probability of king, equals 4 by 52, which in turn is 1 by 30. Now, if the event is provided, for instance, someone looks at the card, that the single card is a face card, then the posterior probability, which is the P of king given it's a face, can be calculated using the Bayes theorem, given that probability of king given its face is equal to probability of the face given it's a king divided by the probability of face into the probability of king. Since every king is also a face card, so the probability of face given it's a king is equal to 1, and since there are 3 face cards in each suit that are jack, king, and queen, the probability of face card is 3 out of 13. Combining these given likelihood ratios, we get the value using the Bayes theorem of probability of king given it's a face is equal to 1 out of 3. So for a joint probability distribution over the events A and B, the probability of A intersection B, which is the conditional probability of A given B, is now defined as probability of A intersection B divided by the probability of B. Now this is how we get the Bayes theorem. Now that we know the different basic proof of how we got the Bayes theorem, so let's have a look at the working of the Bayes theorems with the help of an examples here. So let's take the same example of the data set of the day's forecasts, in which we had the sunny, rainy, overcast. So first of all, what we're going to do is first we will create a frequency table using each attribute of the data set. So as you can see here, we have the frequency table here for the outlook, humidity, and the wind. So for outlook, we have the frequency table here. We have the frequency table for humidity and the wind. So next what we're going to do is create the probability of sunny given it's a yes, that is 3 out of 10. Find the probability of sunny, which is 5 out of 14, and this 14 comes from the total number of observations there and from yes and no. So similarly, we're going to find the probability of yes also, which is 10 out of 14, which is 0.71. For each frequency table, we'll generate these kind of likelihood tables. So the likelihood of yes given it's a sunny is equal to 0.51. Similarly, the likelihood of no given it's a sunny is equal to 0.40. So here you can look that using Bayes theorem, we have found out the likelihoods of yes given it's a sunny and no given it's a sunny. Similarly, we're going to do the same for likelihood table for humidity and the same for wind. So for humidity, we're going to check the probability of yes given it's high. Humidity is high, and probability of playing no given the humidity is high is we're going to calculate it using the same Bayes theorem. So suppose we have a day with the following values, in which we have the outlook as rain, humidity as high, and wind as weak. Since we discussed the same example earlier with the decision tree, we know the answer. So let's not get ahead of ourselves and let's try to find out the answer using the Bayes theorem. And let's understand how naive Bayes works actually. So first of all, we're going to use the likelihood of yes on that day. So that equals to probability of outlook of rain given it's a yes into probability of humidity high given it's a yes into probability of wind weak given it's a yes into probability of yes. Okay, so that gives us 0.019. Similarly, the likelihood of no on that day is the outlook is rain given it's a no, humidity is high given it's a no, and wind is weak given it's a no. That equals to 0.016. Now what we're going to do is find the probability of yes and no, and for that what we're going to do is take the probability, the likelihood, and divide it with the sum of the likelihoods of yes and no. So in that way, we're going to get the probability of yes overall. So using that formula, we get the probability of yes as 0.55 and the probability of no as 0.45. And our model predicts that there is a 55% chance that there will be game tomorrow. If it's rainy, the humidity is high and the wind is weak. Now, if we have a look at the industrial use cases of naive Bayes, we have news categorization as what happens is that the news comes in a lot of tags and it has to be categorized so that the user gets the information he needs in a particular format. Then again, we have spam filtering, which is one of the major use cases of naive Bayes classifier, as it classifies the email as spam or ham. Then finally, we have weather prediction also, as we saw just with the example that we predict whether we're going to play or not. That sort of prediction is always there. So guys, this was all about supervised learning. We discussed linear regression, logistic regression, we discussed naive Bayes, we discussed the random forest, decision tree, and we understood how the random forest is better than decision tree. In some cases, it might be equal to decision tree, but nonetheless, it's always going to provide us a better result. So guys, that was all about the supervised learning. But before that, let's go ahead and see how exactly we're going to implement naive Bayes. So guys, here we have another data set, run or walk. It's the kinematic data sets, and it has been measured using the mobile sensors. So let the target variable be y, assign all the columns after it to x. Using scikit-learn naive Bayes model, we're going to observe the accuracy, generate a classification report using scikit-learn. Now we're going to repeat the model once, only the acceleration values as predictors, and then using only the gyro value as predictors. And we're going to comment on the difference in accuracy between the two models. So here we have a data set which is run or walk. So let me open that for you. So here I have a data set run or walk. So as you can see, we have the date, time, username, risk, activity, acceleration, x, y, acceleration is g, gyro x, gyro y, gyro z. So based on it, let's see how we can implement the naive Bayes classifier. So first of all, what we're going to do is import pandas at PD. Then we're going to import matplotlib for plotting. We're going to read the run or walk data file with pandas pd.read_csv. Let's have a look at the info. So first of all, we see that we have 88,588 rows with 11 columns. So we have the date, time, username, rest, activity, acceleration XYZ, gyro XYZ, and the memory usage is 7.4 MB data. So this is how you look at the columns, df.columns. Now again, we're going to split the data set into training and testing data sets. So we're going to use the train test split model. So that's what we're going to do is split it into xtrain, xtest, ytrain, ytest, and we're going to split it into the size of 0.2 here. So again, I'm saying it depends on you what is the test size. So let's print the shape of the training and see it's 70,000 observation and 6 columns. Now what we're going to do is from the scikit-learn.naive Bayes, we're going to import the Gaussian NB, which is the Gaussian naive Bayes. And we're going to put the classifier as Gaussian NB. Then we'll pass on the xtrain and ytrain variables to the classifier. And again, we have the y_predict, which is the classifier predict x test. And we're going to compare the y_predict with the y_test to see the accuracies for that. So for that, we're going to import sklearn.metrics. We're going to import the accuracy score. Now let's compare both of these. So the accuracy what we get is 95.54%. Now another way is to get a confusion matrix built. So from scikit-learn.metrics, we're going to import the confusion matrix, and we're going to plot the matrix of y_predict and y_test. So as you can see here, we have 90 and 699. That's a very good number. So now what we're going to do is create a classification report. So from metrics, we're going to import the classification reports. We're going to put the target names as walk, run, and print the report using ytest and ypredict with the target names we have. So for walking, we get the precision of 0.92 and the recall of 0.99. F1 score is 0.96. The support is 8,673. And for run, we have precision of 99% with the recall of 0.92 and F1 score of 0.95. So guys, this is how you exactly use the Gaussian NB or the naive Bayes classifier on it. And all of these types of algorithms which are present in the supervised or unsupervised or reinforcement learning are all present in the scikit-learn library. So once again, I say sklearn is a very important library when you're dealing with machine learning, because you do not have to code any algorithm, hard code any algorithm. Every algorithm is present there. All you have to do is just pass the data, split the data set into training and testing data set, and then again, you have to find the predictions and then compare the predicted y with the test case y. So that is exactly what we do every time we work on a machine learning algorithm. Now guys, that was all about supervised learning. Let's go ahead and understand what exactly is unsupervised learning. So sometimes the given data is unstructured and unlabeled, so it becomes difficult to classify the data into different categories. So unsupervised learning helps to solve this problem. This learning is used to cluster the input data in classes on the basis of their statistical properties. So for example, we can cluster different bikes based upon their speed limit, their acceleration, or the average that they are giving. So unsupervised learning is a type of machine learning algorithm used to draw inferences from datasets consisting of input data without labeled responses. So if you have a look at the workflow or the process flow of unsupervised learning, so the training data is collection of information without any label. We have the machine learning algorithm, and then we have the clustering models. So what it does is that distributes the data into different clusters. And again, if you provide any unlabeled new data, it will make a prediction and find out to which cluster that particular data or the data set belongs to, or the particular data point belongs to. So one of the most important algorithms in unsupervised learning is clustering. So let's understand exactly what is clustering. So clustering basically is the process of dividing the datasets into groups consisting of similar data points. And it means grouping of objects based on the information found in the data, describing the objects or their relationships. So clustering models focus on identifying groups of similar records and labeling records according to the group to which they belong. Now, this is done without the benefit of prior knowledge about the groups and their characteristics. And in fact, we may not even know exactly how many groups are there to look for. Now, these models are often referred to as unsupervised learning models since there is no external standard by which to judge the model's classification performance. There are no right or wrong answers to these models. And if we talk about why clustering is used, so the goal of clustering is to determine the intrinsic group in a set of unlabeled data. Sometimes the partitioning is the goal, or the purpose of clustering algorithm is to make sense of an exact value from the large set of structured and unstructured data. So that is why clustering is used in the industry. And if you have a look at the various use cases of clustering in the industry, so first of all, it's being used in marketing. So discovering distinct groups in customer databases, such as customers who make a lot of long distance calls, customers who use internet more than calls. They're also used in insurance companies, so like identifying groups of corporation insurance policy holders with high average claim rate, farmers crash crops, which is profitable. They are used in seismic studies, identifying probable areas of oil or gas exploration based on seismic data. And they're also used in the recommendation of movies. If you'd say they are also used in Flickr photos, they're also used by Amazon for recommending the product which category it lies in. So basically, if we talk about clustering, there are three types of clustering. So first of all, we have the exclusive clustering, which is the hard clustering. So here an item belongs exclusively to one cluster, not several clusters, and the data point belong exclusively to one cluster. So an example of this is the k-mean clustering. So k-mean clustering does this exclusive kind of clustering. So secondly, we have overlapping clustering. So it is also known as soft clusters. In this, an item can belong to multiple clusters as its degree of association with each cluster is shown. And for example, we have fuzzy or the C-means clustering, which is being used for overlapping clustering. And finally, we have the hierarchical clustering. So when two clusters have a parent-child relationship or a tree-like structure, then it is known as hierarchical cluster. So as you can see here from the example, we have a parent-child kind of relationship in the cluster given here. So let's understand what exactly is k-means clustering. So k-means clustering is an algorithm whose main goal is to group similar elements of data points into a cluster. And it is the process by which objects are classified into a predefined number of groups so that they are as much dissimilar as possible from one group to another group, but as much as similar or possible within each group. Now, if you have a look at the algorithm working here, you're right. So first of all, it starts with identifying the number of clusters, which is k. Then again, we find the centroid. We find the distance object to the centroid, distance of objects to the centroid. Then we find the grouping based on the minimum distance. Has the centroid converged? If true, then we make a cluster. If false, we then again find the centroid. Repeat all of the steps again and again. So let me show you how exactly clustering works with an example here. So first we need to decide the number of clusters to be made. Now, another important task here is how to decide the important number of clusters or how to decide the number of clusters. We'll get into that later. So first, let's assume that the number of clusters we have decided is 3. So after that, then we provide the centroids for all the clusters, which is guessing. The algorithm calculates the Euclidean distance of the point from each centroid and assigns the data point to the closest cluster. Now, Euclidean distance, all of you know, is the square root of the distance, the square root of the square of the distance. So next, when the centroids are calculated again, we have our new clusters. For each data point, then again, the distance from the points to the new clusters are calculated, and then again, the points are assigned to the closest cluster. And then again, we have the new centroid is calculated. Now, these steps are repeated until we have a repetition in the centroids, or the new centroids are very close to the very previous ones. So until and unless our output gets repeated or the outputs are very, very close enough, we do not stop this process. We keep on calculating the Euclidean distance of all the points to the centroids. Then we calculate the new centroids, and that is how k-means clustering works basically. So an important part here is to understand how to decide the value of k, or the number of clusters, because it does not make any sense if you do not know how many clusters you're going to make. So to decide the number of clusters, we have the elbow method. So let's assume, first of all, compute the sum squared error, which is the SSE, for some value of k. For example, let's take 2, 4, 6, and 8. Now the SSE, which is the sum squared error, is defined as a sum of the squared distance between each member of the cluster and its centroid mathematically. And if you mathematically, it is given by the equation which is provided here. And if you plot the k against the SSE, you will see that the error decreases as k gets large. Now this is because the number of cluster increases, they should be smaller, so the distortion is also smaller. Now the idea of the elbow method is to choose the k at which the SSE decreases abruptly. So for example here, if we have a look at the figure given here, we see that the best number of cluster is at the elbow. So as you can see here, the graph here changes abruptly at the number 4. So for this particular example, we're going to use 4 as the number of cluster. So first of all, while working with k-means clustering, there are 2 key points to know. First of all, be careful about where you start. So choosing the first center at random, choosing the second center that is far away from the first center. Similarly, choosing the nth center as far away as possible from the closest of all the other centers. And the second idea is to do as many runs of k-means, each with different random starting points, so that you get an idea of where exactly and how many clusters you need to make, and where exactly the centroid lies, and how the data is getting converged. Now, k-means is not exactly a very good method, so let's understand the pros and cons of k-means clustering. We know that k-means is simple and understandable. Everyone learns it at the first go. The items automatically assigned to the clusters. Now, if we have a look at the cons. So first of all, one needs to define the number of clusters. This is a very heavy task as if we have 3, 4, or if we have 10 categories, and if we do not know what the number of clusters are going to be, it's very difficult for anyone to guess the number of clusters. Now, all the items are forced into the clusters. Whether they actually belong to any other cluster or any other category, they are forced to lie in that other category in which they are closest to. Now, this again happens because of the number of clusters with not defining the correct number of clusters, or not being able to guess the correct number of clusters. And most of all, it's unable to handle the noisy data and the outliners, because anyways, machine learning engineers and data scientists have to clean the data. But then again, it comes down to the analysis what they are doing and the method that they are using. So typically people do not clean the data for k-means clustering, or even if they clean, there are noisy and outliners data which affect the whole model. So that was all for k-means clustering. So what we're going to do is now use k-means clustering for the movie data set. So we have to find out the number of clusters and divide it accordingly. So the use case is that first of all, we have a data set of 5,000 movies, and what we want to do is group the movies into clusters based on the Facebook likes. So guys, let's have a look at the demo here. So first of all, what we're going to do is import deep copy, numpy, pandas, seaborn. the various libraries which we're going to use now. And from matplotlib, we're going to use pyplot, and we're going to use this ggplot. And next, what we're going to do is import the dataset and look at the shape of the dataset. So if we have a look at the shape of the dataset, we can see that it has 5,043 rows with 28 columns. And if you have a look at the head of the dataset, we can see it has 5,043 data points. So what we're going to do is place the data points in the plot. We take the director Facebook likes, and if we have a look at the data columns, we have face, number, and poster, cast, total Facebook likes, director Facebook likes. So what we have done here now is taking the director Facebook likes and the actor 3 Facebook likes, right? So we have 5,043 rows and 2 columns. Now using the k-means from sklearn, what we're going to do is import it first. We're going to import k-means from sklearn.cluster. Remember guys, sklearn is a very important library in Python for machine learning. And the number of cluster, what we're going to do is provide as 5. Now this again, the number of cluster depends upon the SSE, which is the sum squared errors, or we're going to use the elbow method. So I'm not going to go into the details of that again. So we're going to fit the data into the k-means.fit, and if we find the cluster centers then for the k-means and print it, so what we find is an array of 5 clusters, and if we print the label of the k-means cluster. Now next what we're going to do is plot the data which we have with the clusters, with the new data clusters which we have found. And for this we're going to use the seaborn, and as you can see here, we have plotted the data into the grid, and you can see here we have 5 clusters. So probably what I would say is that the cluster 3 and the cluster 0 are very, very close. So it might depend. See, that's exactly what I was going to say, is that initially the main challenge in k-means clustering is to define the number of centers, which are the k. So as you can see here, the third center and the 0th cluster, the third cluster and the 0th cluster are very, very close to each other. So guys, it probably could have been in one another cluster. And the another disadvantage was that we do not exactly know how the points are to be arranged. So it's very difficult to force the data into any other cluster, which makes our analysis a little different. Works fine, but sometimes it might be difficult to code in the k-means clustering. Now let's understand what exactly is c-means clustering. So the fuzzy c-means is an extension of the k-means clustering. The popular simple clustering technique. So fuzzy clustering, also referred as soft clustering, is a form of clustering in which each data point can belong to more than one cluster. So k-means tries to find the hard clusters where each point belongs to one cluster, whereas the fuzzy c-means discovers the soft clusters. In a soft cluster, any point can belong to more than one cluster at a time with a certain affinity value towards each. Fuzzy c-means assigns the degree of membership, which ranges from 0 to 1 to an object to a given cluster. So there is a stipulation that the sum of fuzzy membership of an object to all the cluster it belongs to must be equal to 1. So the degree of membership of this particular point to both of these clusters are 0.6 and 0.4. And if we add up, we get 1. So that is one of the logic behind the fuzzy c-means. And this affinity is proportional to the distance from the point to the centroid of the cluster. Now then again, we have the pros and cons of fuzzy c-means. So first of all, it allows a data point to be in multiple clusters. That's a pro. It's a more neutral representation of the behavior of genes. Genes usually are involved in multiple functions. So it is a very good type of clustering when we're talking about genes. And again, if we talk about the cons, again, we have to define C, which is the number of clusters, same as K. Next, we need to determine the membership cutoff value also. So that takes a lot of time, and it's time consuming, and the clusters are sensitive to initial assignment of centroids. So a slight change or a deviation from the centroids is going to result in a very different kind of, a funny kind of output we get from the fuzzy c-means. And one of the major disadvantages of c-means clustering is that it is a non-deterministic algorithm. So it does not give you a particular output as in such. That's that. Now let's have a look at the third type of clustering, which is the hierarchical clustering. So hierarchical clustering is an alternative approach which builds a hierarchy from the bottom up or the top to bottom and does not require to specify the number of clusters beforehand. Now the algorithm works as in, first of all, we put each data point in its own cluster, identify the closest to cluster and combine them into one more cluster. Repeat the above step till the data points are in a single cluster. Now there are two types of hierarchical clustering. One is agglomerative clustering and the other one is division clustering. So agglomerative clustering builds the dendrogram from bottom level, while the division clustering, it starts all the data points in one cluster, the root cluster. Now again, hierarchical clustering also has some sort of pros and cons. So in the pros, though no assumption of a particular number of clusters is required, and it may correspond to meaningful taxonomies. Whereas if we talk about the cons, once a decision is made to combine two clusters, it cannot be undone. And one of the major disadvantages of these hierarchical clustering is that it becomes very slow if we talk about very, very large data sets. And nowadays, I think every industry are using large data sets and collecting large amounts of data. So hierarchical clustering is not the apt or the best method someone might need to go for. So there's that. Now, when we talk about unsupervised learning, so we have k-means clustering, and again, there's another important term which people usually miss while talking about unsupervised learning, and there's one very important concept of market basket analysis. Now, it is one of the key techniques used by large retailers to uncover association between items. Now, it works by looking for a combination of items that occur together frequently in the transactions. To put it in another way, it allows retailers to identify the relationships between the items that the people buy. For example, people who buy bread also tend to buy butter. The marketing teams at the retail stores should target customers who buy bread and butter and provide them an offer so that they buy a third item like an egg. So if a customer buys bread and butter and sees a discount or an offer on eggs, he will be encouraged to spend more money and buy the eggs. Now, this is what market basket analysis is all about. Now, to find the association between the two items and make predictions about what the customers will buy, there are two algorithms, which are the association rule mining and the Apriori algorithms. So let's discuss each of these algorithms with an example. First of all, if we have a look at the association rule mining, now it's a technique that shows how items are associated to each other. For example, customers who purchase bread have a 60% likelihood of also purchasing jam, and customers who purchase laptop are more likely to purchase laptop bags. Now, if we take an example of an association rule, if we have a look at the example here, A arrow B, it means that if a person buys an item A, then he will also buy an item B. Now, there are three common ways to measure a particular association because we have to find these rules on the basis of some statistics, right? So what we do is use support, confidence, and lift. Now these three common ways and the measures to have a look at the association rule mining and know exactly how good is that rule. So first of all, we have support. So support gives the fraction of the transaction which contains an item A and B. So it's basically the frequency of the item in the whole item set. Whereas confidence gives how often the item A and B occur together given the number of times A occur. So it's frequency A comma B divided by the frequency of A. Now, lift what indicates is the strength of the rule over the random co-occurrence of A and B. If you have a close look at the denominator of the lift formula here, we have support A into support B. Now, a major thing which can be noted from this is that the support of A and B are independent here. So if the value of lift or the denominator value of the lift is more, it means that the items are independently selling more, not together. So that in turn will decrease the value of lift. So what happens is that suppose the value of lift is more, that implies that the rule which we get, it implies that the rule is strong and it can be used for later purposes. Because in that case, the support A into support B value, which is the denominator of lift, will be low, which in turn means that there's a relationship between the items A and B. So let's take an example of association rule mining and understand how exactly it works. So let's suppose we have a set of items A, B, C, D, and E. And we have the set of transactions which are T1, T2, T3, T4, and T5. And what we need to do is create some sort of rules. For example, you can see A, D, which means that if a person buys A, he buys D. If a person buys C, he buys A. If a person buys A, he buys C. And for the fourth one is if a person buys B and C, he'll in turn buy A. Now, what we need to do is calculate the support, confidence, and lift of these rules. Now, here again, we talk about Apriori algorithm. So Apriori algorithm and the association rule mining go hand in hand. So what Apriori does is algorithm, it uses the frequent item sets to generate the association rules. And it is based on the concept that a subset of a frequent item set must also be a frequent item set. So let's understand what is a frequent item set and how all of these work together. So if we take the following transactions of items, we have transaction T1 to T5, and the items are 134, 235, 1235, 25, and 135. Now, another more important thing about support, which I forgot to mention, was that when talking about association rule mining, there is a minimum support count, what we need to do. Now, the first step is to build a list of item set of size 1 using this transaction data set and use the minimum support count too. Now, let's see how we do that. If we create the table C1, if you have a close look at the table C1, we have the item set 1, which has a support 3 because it appears in the transaction 1, 3, and 5. Similarly, if we have a look at the item set, the single item 3, so it has a support of 4. It appears in T1, T2, T3, and T5. But if we have a look at the item set 4, it only appears in the transaction 1, so its support value is 1. Now, the item set with the support value which is less than the minimum support value, that is 2, have to be eliminated. So the final table, which is a table F1, has 1, 2, 3, and 5. It does not contain the 4. Now, what we're going to do is create the item list of the size 2. And all the combination of the item sets in F1 are used in this iteration. So we've left 4 behind. We just have 1, 2, 3, and 5. So the possible item sets are 1, 2, 1, 3, 1, 5, 2, 3, 2, 5, and 3, 5. Then again, we'll calculate the support. So in this case, if we have a closer look at the table C2, we see that the item set 1, 2 is having a support value 1, which has to be eliminated. So the final table F2 does not contain 1, 2. Similarly, if we create the item sets of size 3 and calculate the support values, but before calculating the support, let's perform the purging on the data set. Now, what's purging? So after all the combinations are made, we divide the table C3 items to check if there are another subset whose support is less than the minimum support value. This is Apriori algorithm. So in the item sets 1, 2, 3, what we can see that we have 1, 2, and in the 1, 2, 5 again we have 1, 2. So we'll discard both of these item sets and we'll be left with 1, 3, 5 and 2, 3, 5. So with 1, 3, 5 we have 3 subsets 1, 5, 1, 3, 3, 5, which are present in table F2. Then again we have 2, 3, 2, 5, and 3, 5, which are also present in table F2. So we have to remove 1, 2 from the table C3 and create the table F3. Now, if we're using the items of C3 to create the items of C4, so what we find is that we have the item set 1, 2, 3, 5. The support value is 1, which is less than the minimum support value of 2. So what we're going to do is stop here and we're going to return to the previous item set, that is the table C3. So the final table F3 was 135 with the support value of 2 and 235 with the support value of 2. Now what we're going to do is generate all the subsets of each frequent item sets. So let's assume that our minimum confidence value is 60%. So for every subset S of I, the output rule is that S gives I to S, is that S recommends I and S. If the support of I divided by the support of S is greater than or equal to the minimum confidence value, then only we'll proceed further. So keep in mind that we have not used lift till now. We are only working with support and confidence. So applying rules to the item sets of F3, we get rule 1, which is 1, 3, which gives 1, 3, 5 and 1, 3. It means if you buy 1 and 3, there's a 66% chance that you'll buy item 5 also. Similarly, the rule 1 comma 5, it means that if you buy 1 and 5, there's 100% chance that you will buy 3 also. Similarly, if we have a look at rule 5 and 6, here the confidence value is less than 60%, which was the assumed confidence value. So what we're going to do is we'll reject these files. Now, an important thing to note here is that have a closer look to the rule 5 and rule 3. You see it has 153, 153, 315. It's very confusing. So one thing to keep in mind is that the order of the item sets is also very important. That will help us create good rules and avoid any kind of confusion. So that's that. So now let's learn how association rules are used in market basket analysis problems. So what we'll do is we'll be using the online transactional data of a retail store for generating association rules. So first of all, what you need to do is import pandas, MLXD&D libraries from the imported and read the data. So first of all, what we're going to do is read the data. What we're going to do is from mlxtnd.frequent patterns, we're going to import the a priori and the association rules. As you can see here, we have the head of the data. You can see we have invoice number, stock code, the description, quantity, the invoice detail, unit price, customer ID, and the country. So in the next step, what we will do is we will do the data cleanup, which includes removing spaces from some of the descriptions given. And what we're going to do is drop the rows that do not have the invoice numbers and remove the credit transactions. So here what we're going to do is remove which do not have an invoice number. If the string contains type C invoice number, then we're going to remove that. Those are the credits. Remove any kind of spaces from the descriptions. So as you can see here, we have like 532,000 rows with 8 columns. So next, what we're going to do is after the cleanup, we need to consolidate the items into one transaction per row with each product. For the sake of keeping the data set small, we're going to only look at the sales for France. So we're going to use the only France and group by invoice number, description with the quantity, sum up and see. So which leaves us with 392 rows and 1563 columns. Now there are a lot of zeros in the data, but we also need to make sure any positive values are converted to a 1 and anything less than 0 is set to 0. So for that we're going to use this code defining encode units. If x is less than 0, return 0. If x is greater than 1, return 1. So what we're going to do is map and apply it to the whole data set we have here. So now that we have structured the data properly, so the next step is to generate the frequent item set that has support of at least 7%. Now this number is chosen so that you can get close enough. Now what we're going to do is generate the rules with the corresponding support, confidence, and lift. So we have given the minimum support as 0.7, the metric is lift, frequent item set, and threshold is 1. So these are the following rules. Now a few rules with a high lift value, which means that it occurs more frequently than would be expected given the number of transactions and the product combinations. Most of the places the confidence is high as well. So these are few of the observations what we get here. If we filter the data frame using the standard pandas code for large lift 6 and high confidence 0.8, this is what the output is going to look like. These are 1, 2, 3, 4, 5, 6, 7, 8. So as you can see here, we have the 8 rules, which are the final rules which are given by the association rule mining. And that is how all the industries or any of these, which talk about large retailers, they tend to know how their products are used and how exactly they should rearrange and provide the offers on the products so that people spend more and more money and time in their shop. So that was all about association rule mining. So guys, that's all for unsupervised learning. I hope you got to know about the different formulas, how unsupervised learning works. Because we did not provide any label to the data. All we did was create some rules and not knowing what the data is. And we did clusterings, different types of clusterings, k-means, c-means, hierarchical clustering. So now coming to the third and last type of learning is the reinforcement learning. So what reinforcement learning is, it's a type of machine learning where an agent is put in an environment and it learns to behave in this environment by performing certain actions and observing the rewards which it gets from those actions. So reinforcement learning is all about taking an appropriate action in order to maximize the reward in the particular situation. And in supervised learning, the training data comprise of input and the expected output. So the model is trained with the expected output itself. But when it comes to reinforcement learning, there is no expected output. The reinforcement agent decides what actions to take in order to perform a given task. In the absence of a training dataset, it is bound to learn from its expertise. So let's understand reinforcement learning with an analogy. So consider a scenario wherein a baby is learning how to walk. Now, this scenario can go in two ways. First, the baby starts walking and makes it to the candy. Now, since the candy is the end goal, the baby is happy, it's positive. The baby is happy, positive reward. Now, coming to the second scenario, the baby starts walking but falls due to some hurdle in between. Now, the baby gets hurt and does not get to the candy, it's negative. The baby is sad, negative reward. Just like we humans learn from our mistakes by trial and error, reinforcement learning is also similar. We have an agent, which is a baby, a reward, which is candy, and many hurdles in between. The agent is supposed to find the best possible path to reach the reward. So guys, if you have a look at some of the important reinforcement learning definitions, first of all, we have the agent. So the reinforcement learning algorithm that learns from trial and error, that's the agent. Now, if we talk about environment, the world through which the agent moves or the obstacles which the agent has to conquer are the environment. Now, actions A are all the possible steps that the agent can take. The state S is the current conditions returned by the environment. Then again, we have reward R, an instant return for the environment to appraise the last action. Then again, we have policy, which is pi. It is the approach that the agent uses to determine the next action based on the current state. We have value V, which is the expected long-term return with discount as open to the short-term reward R. Then again, we have the action value Q. This is similar to value except it takes an extra parameter, which is the current state action, which is A. Now let's talk about reward maximization for a moment. Now, reinforcement learning agent works based on the theory of reward maximization. This is exactly why the RL agent must be trained in such a way that he takes the best action so that the reward is maximum. Now, the collective rewards at a particular time and the respective action is written as GT equals RT plus 1, RT plus 2, and so on. Now, the equation is an ideal representation of rewards. Generally, things do not work out like this while summing up the cumulative rewards. Now, let me explain this with a small game. In the figure, you see a fox, right? Some meat and a tiger. Our reinforcement learning agent is the fox, and his end goal is to eat the maximum amount of meat before being eaten by the tiger. Since this fox is a clever fellow, he eats the meat that is closer to him, rather than the meat which is close to the tiger. Because the closer he goes to the tiger, the higher are his chances of getting killed. As a result, the reward near the tiger, even if they are bigger meat chunks, will be discounted. This is done because of the uncertainty factor that the tiger might kill the fox. Now, the next thing to understand is how discounting of reward works. Now, to do this, we define a discount called the gamma. The value of gamma is between 0 and 1. The smaller the gamma, the larger the discount, and vice versa. So our cumulative discounted reward is GT summation of k 0 to infinity gamma to the power k RTK RT plus k plus 1, where gamma belongs to 0 to 1. But if the fox decides to explore a bit, it can find bigger rewards, that is big chunk of meats. This is called exploration. So the reinforcement learning basically works on the basis of exploration and exploitation. So exploitation is about using the already known exploited information to heighten the rewards, whereas exploration is all about exploring and capturing more information about the environment. There is another problem which is known as the K-armed bandit problem. The K-armed bandit is a metaphor representing a casino slot machine with K pull levers or arms. The user or the customer pulls any one of the levers to win a predicted reward. Now, the objective is to select the lever that will provide the user with the highest reward. Now, here comes the Epsilon greedy algorithm. It tries to be fair to two opposite goals of exploration and exploitation by using a mechanism of flipping a coin. Just like if you flip a coin and it comes up head, you should explore for a moment, but it comes up tails, you should exploit. It takes whatever action seems best at the present moment. So, with probability 1, epsilon, the epsilon greedy algorithm exploits the best known option. With probability epsilon by 2, the algorithm explores the best known option, and with the probability epsilon by 2, the algorithm explores the best known option, and with the probability epsilon by 2, the epsilon greedy algorithm explores the worst known option. Now let's talk about Markov decision process. The mathematical approach for mapping a solution in reinforcement learning is called Markov decision process, which is MDP. In a way, the purpose of reinforcement learning is to solve a Markov decision process. Now, the following parameters are used to attain a solution. Set of actions A, set of states S, we have the reward R, policy pi, and the value V. And we have transition function T, probability that a form leads to S. Now, to briefly sum it up, the agent must take up an action A to transition from the start state to end state S. While doing so, the agent receives the reward R for each action he takes. The series of actions taken by the agent define the policy pi, and the rewards collected define the value V. The main goal here is to maximize the rewards by choosing the optimum policy. Now let's take an example of choosing the shortest path. Now consider the given example here. So what we have is, given the above representation, our goal here is to find the shortest path between A and D. Each edge has a number linked to it, and this denotes the cost to traverse that edge. Now the task at hand is to traverse from point A to D with the minimum possible cost. In this problem, the set of states are denoted by the nodes A, B, C, and D. The action is to traverse from one node to another are given by A arrow B or C arrow D. Reward is the cost represented by each edge, and the policy is the path taken to reach each destination, A to C to D. So you start off at node A and take baby steps to your destination. Initially, only the next possible node is visible to you. If you follow the greedy approach and take the most optimal step, that is choosing A to C instead of A to B or C, now you are at node C and want to traverse to node D. You must again choose the path wisely. Choose the path with the lowest cost. We can see that ACD has the lowest cost, and hence we take that path. To conclude, the policy is A to C to D, and the value is 120. So guys, let's understand Q-learning algorithm, which is one of the most used reinforcement learning algorithm, with the help of an example. So we have 5 rooms in a building connected by doors, and each room is numbered from 0 through 4. The outside of the building can be thought of as one big room, which is the room number 5. Now, doors 1 and 4 lead into the building from the room 5 outside. Now let's represent the rooms on a graph, and each room as a node, and each door as a link. So as you can see here, we have represented it as a graph, and our goal is to reach the node 5, which is the outer space. So what we're going to do is, the next step is to associate a reward value to each door. So the doors that directly lead to the goal have a reward of 100, whereas the doors that do not directly connect to the target have a 0 reward. And because the doors are two-way, 2 arrows are assigned to each room, and each row contains an instant reward value. So after that, the terminology in the Q-learning includes the term states and actions. So the room 5 represents a state. Agent's movement from one room to another room represents an action. And in this figure, a state is depicted as a node, while an action is represented by the arrows. So for example, let's take an agent that travels from room 2 to the room 5. So the initial state is going to be the state 2. Then the next step is from stage 2 to stage 3. Next, it moves from stage 3 to stage either 2, 1, or 4. So if it goes to the 4, it reaches stage 5. So that's how you represent the whole traversing of any particular agent in all of these rooms, and represents their actions via nodes. So we can put this state diagram and instant reward values into a reward table, which is the matrix R. So as you can see, the -1 here in the table represents the null values, because you cannot go from 1 to 1, right? And since there is no way to go from 1 to 0, So that is also -1. So -1 represents the null values, whereas the 0 represents 0 reward and 100 represents the reward going to the room 5. So one more important thing to know here is that if you're in room 5 and if you go to room 5, the reward is 100. So what we need to do is add another matrix Q representing the memory of what the agent has learned through experience. The rows of matrix Q represent the current state of the agent, whereas the columns represent the possible action leading to the next state. Now, the formula to calculate the Q matrix is if a particular Q at a particular state and the given action is equal to the R of that state and action plus gamma, which we discussed earlier, the gamma parameter, which we discussed earlier, which ranges from 0 to 1, into the maximum of the Q or the next state, comma, all actions. So let's understand this with an example. So here are the 9 steps which any Q learning algorithm particularly has. So first of all is to set the gamma parameter and the environment rewards in the matrix R. Then we need to do is initialize the matrix Q to 0, select the random initial state, set the initial state to current state, select one among all the possible actions for the current state. Using this possible action, consider going to the next state. When you get the next state, get the maximum Q value for this next state based upon all the actions. Compute the Q value using the formula. Repeat the above steps until the current state equals your goal. So the first step is to set the values of the learning parameters gamma, which is 0.8, and the initial state as room number 1. So the next, initialize the Q matrix as 0 matrix. So on the left hand side, as you can see here, we have the Q matrix, which has all the values as 0. Now from room 1, you can either go to room 3 or room 5. So let's select room 5 because that's our end goal. So from room 5, calculate the maximum Q value for this next state based on all possible actions. So Q1, 5 equals R1, 5, which is 100 plus 0.8, which is the gamma, into the maximum of Q 5, 5, 4, and 5, 5. So the maximum of 5, 1, 5, 4, and 5, 5 is 100. So the Q values from initially, as you can see here, the Q values are initialized to 0, so it does not matter as of now. So the maximum is 0. So the final Q value for Q1, 5 is 100. So that's how we're going to update our Q matrix. So Q matrix, the position as 1, 5 in the second row gets updated to 100. So the first step we have done right now. For the next episode, we start with a randomly chosen initial state. So let's assume that the stage is 3. So from room number 3, you can either go to room number 1, 2, or 4. So let's select the option of room number 1 because from our previous experience, what we've seen is that 1 is directly connected to room number 5. So from room number 1, calculate the maximum Q value for this next state based on all possible action. So 3, 1, if we take, we get R3, 1 plus 0.8 gamma into maximum of these. We get the value as 80. So the matrix Q gets updated. Now for the next episode, the next state 1 now becomes the current state. We repeat the inner loop of the Q learning algorithm because state 1 is not the goal state. From 1, you can either go to 3 or 5. So let's select room number 5 as that's our goal. So from room number 5, again, we can go from all of these. So the Q matrix remains the same since Q15 is already fed to the agent. And that is how you select the random starting points and fill up the Q matrix and see which path will lead us there with the maximum reward points. Now what we're going to do is do the same coding using the Python in machine learning. So what we're going to do is import numpy as np. We're going to take the R matrix as we defined earlier so that the -1 are the null values, zeros are the values which provides the 0, and hundreds is the value. So what we're going to do is initialize the Q matrix now to 0. We're going to put gamma as 0.8 and set the initial state as 1. Now here returns all the available actions in the state given as an argument. So if we define the available action with the given state, we get the available action in the current state. So we have the another function here which is known as a sample next action. What this function does is that chooses at random which action to be performed within the range of all the available actions. And finally we have action which is the sample next action with the available act. Now again we have another function which is update. Now what it does is that it updates the Q matrix according to the path selected and the Q learning algorithm. So initially our Q matrix is all 0. So what we're going to do is we're going to train it over 10,000 iterations, and let's see what exactly gives the output of the Q value. So if the agent learns more through further iterations, it will finally reach convergence value in Q matrix. So the Q matrix can then be normalized, that is converted to percentage by dividing all the non-zeros entities by the highest number, which is 500 in this case. So once the matrix Q gets close enough to the state of convergence, agent has learned the most optimal path to the goal state. So what we're going to do next is divide it by 5, which is the maximum here. So Q divided by NPQ max into 100 so that we get it normalized. Now once the Q matrix gets close enough to the state of convergence, the agent has learned all the paths. So the optimal path given by the Q learning algorithm is if it starts from 2, it'll go to 3, then go to 1, and then go to 5. If it starts at 2, it can go to 3, then 4, then 5. That will give us the same result. So as you can see here, the output given by the Q learning algorithm is the selected path is 2, 3, 1, and 5, starting from the Q state 2. So this is how exactly a reinforcement learning algorithm works. It finds the optimal solution using the path, given the action and rewards, and the various other definitions or the various other challenges, I would say. Actually, the main goal is to get the maximum reward and get the maximum value through the environment, and that's how an agent learns, through its own path and through going millions and millions of iterations, learning how each path will give us what reward. So that's how the Q learning algorithm works, and that's how it works in Python as well, as I showed you. So guys, this is all about reinforcement learning, and I hope you got to know about the Markov decision process, how Q learning works. And with this, guys, we come to an end of this machine learning session. I hope you guys got to know about machine learning, how it is used in the industries, the various applications of machine learning, the various types of machine learning, supervised, unsupervised, reinforcement, the various algorithms used in machine learning. There are n number of algorithms. These are just few of those algorithms. So guys, Edureka, as we know, provides a machine learning in Python course. They also provide a machine learning engineer course, which is the master program, which is more aligned and structured. So these courses will not only provide you with the skills, and it will also help you to learn those skills in the correct order. So guys, if you want to know more about these, check out the courses, the link to which is given in the description box below. And if you guys have any doubts and any queries regarding this whole video and the whole demo part, or any other type of queries you have, please feel free to mention it in the comment section below, and we'll revert to it as soon as possible. So guys, thank you for sticking this long for this machine learning full course video. Thank you and happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!